Hello students, welcome to the class of simple machines. Today we'll learn very few things about machines actually. So what does a machine stands for, or why humans have introduced machines? To reduce human effort actually. Now let's see here in this particular portion we can find this guy is trying to cut this timber. He's trying his level best to cut this timber at a very short time, but he have to put lot of effort to cut this timber. To reduce this effort, we humans have introduced in this machine known as chainsaw to cut this timber at a very ease without producing extra effort. Now simple machine is a device that change the direction or magnitude of forces, and in general simplest form of mechanism that uses mechanical advantage to multiply forces are known as simple machines. So there are various simple machines that we find and that we can find every day in our day-to-day life, that we also use every day in our day-to-day life. Now this is the lever arrangement. Here in this lever arrangement we can find that the load is being applied to one part of the lever. This is known as the resistance, and the effort is being produced at the other part of the lever or in the other end of the lever. So the load is at one end and the effort is at other end. The middle end is known as the fulcrum, or this is the pivot, you can say, about which the load and the effort swings around. Okay, so this is the lever arrangement. This is the age old lever arrangement, very old simple machine that we can still use today, and we can find it anywhere, any place basically. So these levers can be of three different type: lever of first kind, lever of second kind, lever of third kind, or third order, second order, first order. Now the first order lever is the lever that is being shown earlier, where the load is on the one side and the force is on the other side. The fulcrum is at the middle, and this practically resembles the connection of head, neck and our shoulder. So our body is also having lot of simple machines, right? And scissor, seesaw, these are the examples of simple machines. Basically seesaw is a very live example of first order lever. First order lever have mechanical advantage greater than 1, less than 1 or equal to 1. Okay, now first order lever, and then how we can identify a first order lever. Load will be on one side, force will be on another side, and the fulcrum will be at the middle, or the pivot will be at the middle. Now lever of the second type, lever of the second order, is in the lever where force will be on one side and load will be at the middle and fulcrum will be on the other side. Now this particular arrangement is known as the force multiplier arrangement, or this particular lever is also known as the force multiplier lever. Our foot ankle area resembles the second order lever. Nutcracker, bottle opener are some of the examples of second order lever. In the lever of third order lever is the lever where fulcrum is on the one side, or fulcrum will be present on one end, load will be present on other end, and the force will be present in the middle. So we are going to produce some effort in the middle, right? We have to produce some force in the middle. This kind of lever always have mechanical advantage less than 1, but this lever can operate at a very high speed, or this lever is also known as speed multiplier lever. Our arm or human hand resembles the speed multiplier lever, or the lever of third order. Now tweezers, hammer or jaw are the examples of lever of third order. Now one of the basic and age old simple machine is the fixed pulley arrangement. Here we can find that there is a drum, and a rope is placed over the drum, and the load is being raised with the help of this particular rope. Now what is happening here, this fixed pulley arrangement, this base, this black one is the base, and this pulley is being fixed to this black base. Okay, and this guy is trying to lift this particular load up. Okay, so he is producing effort on the rope, and this particular thing is going up. Okay, this is the basic arrangement of fixed pulley. And this particular example can be found out in any place where we find wells. People use drums or buckets to lift water from the well. Okay, in those cases, in those places to be precise, we will find this kind of fixed pulley arrangement. Now compound pulley arrangement is something different. Compound pulley have two different pulleys compounded together in such a way that the effort will be less, and the material which is getting lifted will be same, or you can say the effort between the compound pulley and a fixed pulley, application of effort is much more less here in case of compound pulley if the load is taken to be constant, or similar load. In case of similar load, let's say if the load is taken to be as L, and both the pulleys are given effort, then the compound pulley will require less effort to raise that particular load L. So compounding of pulley makes the load feels lighter, and the effort effort required to rise that particular load is much more less. Now one thing most important, we find this particular device everywhere, where this green section is nothing but a bolt, and here we will find a square thread, and this is the nut, and this is the foundation. This bolt is rotated over the nut here, and we have this bar that is helping to rotate this bolt, and we have a thrust bearing on the top and have a crown here which actually holds the load. This arrangement is known as screw jack. This is found in every place where we need to rise a lot of heavy loads, okay, such as to rise a vehicle, to rise entire house. We can apply this particular screw jack. To rise a foundation of a house, we can apply this screw jack. This screw jack is also found. We will also find this screw jack in aircraft horizontal stabilizers, and also in rudders of ship. So this is screw jack. This is one of the oldest form of simple machine that we still use today. Now simple machines have a lot of advantages here. Simple machines usually reduce effort, and extends the ability of people to perform a lot of tasks in a very short period of time. And simple machines widely simple machines include wide ranges of materials like wheel, axle, pulley, inclined planes, weights, levers, etc. Okay, simple machines can also used to reduce the amount of force applied, or can be used to magnify the force applied. Okay, so very practical example of day-to-day simple machine is our door. It is actually hinged, okay, and it is a kind of lever. Okay, so everyday life, in our everyday life, we find machines everywhere. These simple machines we will find everywhere in our everyday life, day-to-day life. We are dependent on these kind of simple machines. So with this I end this particular session, and if you find any difficulty to understand this video, please come up to me, and please comment. If you have any query, just try to contact me, and I'll try to solve your problem. Thank you very much.